I want to introduce our next speaker. Dr. Darrell Wallace is the Deputy Director of Chief Technology Officer for the Texas A&M Engineering Experiment Station, Secure America Institute, where he provides technical leadership to prove the security and resilience of national manufacturing. National manufacturing, that's a cool, people don't think about that, but it's real, right? He's also the founding member and vice chair of ACME Y14.46 Subcommittee on Product Definition for Additive Manufacturing and serves on other related standards committees. He was previously proposal co-author and founding deputy director for America Makes, the National Additive Manufacturing Innovation Institute. His team was responsible for starting the first of the Manufacturing USA Institutes. Dr. Wallace has 30 years of extensive work experience in manufacturing and has used his knowledge and insight to teach future professionals in the industry. Please join me in welcoming Dr. Darrell Wallace.
All right, so I apologize that you get two of me. It's unfortunate. So, good morning. I have the dubious honor of following so many awesome speakers today, and I will do my best to stand up to the high bar that has been set. So, as the bio says, I have what's turned into, it's hard to believe I'm at this point in my career now, but fairly lengthy bio in manufacturing. I worked my way through my undergraduate degree at the Ohio State University in a cold rolling steel plant, working in maintenance there. So I was tearing apart bearing chocks for rolling mills, and of course the dress code for the engineering staff was shirt and tie, so I'm doing that in a shirt and tie. I think I ruined more clothes than the money that I made doing that job. But I got tremendous experience, and I learned to do manufacturing, and I learned to appreciate the doing of manufacturing. And it has shaped my entire career and how I look at the world. So I come to you today as somebody who has lots of really cool experience across a wide range of manufacturing companies, doing a lot of different kinds of manufacturing, from very small startups to Fortune 50, global Fortune 50 manufacturing companies that I've worked with and worked for. I've also, I helped stand up the first Manufacturing USA Institute. I've worked at the highest levels of manufacturing with DoD. So I have while I'm not the expert on any of those things, I do have a fairly unique breadth of perspective. And so I come to you today not as an expert, because I wouldn't presume to claim to be one, but as a manufacturing fan, a true believer in manufacturing, and it's absolute. It's one of the most awesome things about the human experience. It kind of defines the human experience in so many ways, and as a critically important piece of our national security and prosperity. And so I love what's happening here. I've been a part of similar events across the country at various points. I was deeply involved in Northeast Ohio in developing a community very similar to this. Youngstown, Ohio, I think has many similarities to Marshall. And so have lots of thoughts on this, and I'll share some of them today. So Rush had asked me to talk today about advanced manufacturing. I want to first just kind of put some context around how important manufacturing is. Now, I'm going to do an exercise here that I do with a lot of my students as they first come in. So I will ask you to ponder for just a moment. If it was a life or death situation right this moment, somebody's life depended on it, somebody you care a lot about, could you fill a coffee cup right now with something that wasn't manufactured? And it can't come from you or a neighbor or bodily functions or fluids or byproducts, okay? But stop and think about that for a second. Here you sit in a room, much like any other room you might sit in, come up with a coffee cup worth of stuff that wasn't manufactured. In all likelihood, that person you care about is dead where they sit. Our whole world is manufactured. Even the fruit upstairs, if you really get down to it, so much of that fruit, you go to the store, right, it was processed, right? It was sent out, it went through a washing station, it was waxed, had a little sticker stuck on it all through automated equipment. for all intents and purposes, it's a manufactured product. Our world is manufactured, and that's why it is so critically important. And as we've discovered, when our supply chains get disrupted, our world gets disrupted too. And so, so I think it's wonderful that you're focusing as part of your considerations on manufacturing. But then we get to the thing about advanced manufacturing. What is advanced manufacturing? So I would love to just take a couple moments, just a couple examples. Some of you show hands. What's advanced manufacturing? Does anybody have a pet advanced manufacturing thing? Sure. Automation, okay. AI. So I've got automation, AI, anything else? Any manufacturers in the room? What are the critical things you need right now and you think are robotics, okay? Quantum computers. Okay. So typically when I have this type of conversation, what we find is that we talk about advanced manufacturing because everybody wants to be advanced. And if you're going to get money for it, and if you're going to get people excited about it, you don't want to do dull manufacturing. You want to do advanced manufacturing, right? Nobody wants to do boring manufacturing. But the reality is that when we start talking with people, they start to throw out things like 5-axis CNC, 5-axis CNC machining. Okay. But is it advanced? And in my world, advanced is something that is either under development, it's not commercially available, or that has barely touched its commercial potential. It's really not been broadly adopted. 5-axis CNC machining is very advanced, technically sophisticated CNC machining. It takes very skilled operators to do it. It was invented in 1958, okay? A couple years before I was born, okay? A couple years before most of the audience was born, okay? It's not advanced, it's not new, okay? Similarly, we could talk about 3D printing. As my resume says, I've done a lot of work in 3D printing, love 3D printing. But I don't think that you should spend a whole lot of time worrying about it because it's not what you need today. As a community, as a manufacturer, if you need it, trust me, you're going to go get it. But 3D printing isn't one process. We act like it is. It's 7 or more new processes that are all as different from each other as forging is, from casting is, from machining. And so if I put a couple of little 3D printers in a lab and teach you how to do things, I really haven't taught you anything about 3D printing. And the truth is, it's not going to make your manufacturing community really that much stronger. It's probably not the skill set you need. So, I am coming to you as a manufacturing fanatic. I love advanced manufacturing, but I think it's far more important that we talk not about advanced manufacturing, but I'm going to propose to you that we talk about how to advance manufacturing. How do we help the community of Marshall, Texas be on the cutting edge of competitiveness as a manufacturing community? So I'd like to take the next 10 or so minutes that I've got left here to talk about that and what that looks like. So let's start with what manufacturing looks like today. We've heard it time and again, almost every speaker talking about the tough labor market. And there are lots of different sources for this. I'm going to hit on just a couple of those. First, perception of manufacturing. It's still a dirty word. I love manufacturing. I loved it when nobody liked it. I loved it when colleges told me it wasn't a college topic anymore, that we had outgrown it. That's you write in crayon if you study manufacturing. Now everybody wants to be a manufacturer. Yeah, welcome to my party. So we have to change perceptions about it, and there are things that are getting cooler, and honestly the automation and those things are going to make manufacturing, they make manufacturing safer, they make manufacturing faster, they make it a better quality of life kind of job. And so manufacturing is different than it was historically, but I will tell you right now, I work with advanced manufacturers at the DoD, and I also work with companies that are major suppliers to the oil and gas industry, who point out that the newest machine in their building was built in 1953. Now, that is perhaps one of the biggest challenges in manufacturing today, is that spread. Because I guarantee while we're talking about IoT and we're talking about smart manufacturing and AI, there are brand new pieces of equipment and brand new plants. Go to Lockheed Martin and they're building, this full digital twin all the way through the thing. Yeah, well, guess what? Some of their suppliers are still building all their stuff with technology from 1953. And so as we work to understand how to bring that continuum across the 330,000 manufacturers in the United States, 98% of which have fewer than 500 employees, 70% of which have fewer than 20 employees. They are not going to be making Jetsons rockets in their plants. They don't need advanced manufacturing. They just need to be good at manufacturing and be competitive in the realities of what manufacturing is today. Okay? We have a misalignment of skills. K through 12 education is not, I mean, I'm just going to say it as a manufacturing fan, they're not getting it done. Okay? The product that's coming out of our K through 12 system, half of them can't read, 2/3 of them can't do math. And those are the ones showing up in my engineering classes. Okay? It's a problem. It's a problem everywhere. I'm sure it's a problem here because I haven't been any place that it isn't a problem. If you talk about what does manufacturing tomorrow need, we need a baseline expectation of workforce that starts at the lowest levels with just basic competencies. In the collegiate environment, I told you that my professors and I and the people who believed in doing manufacturing really did mostly get disregarded for about 25 years, almost run out. Now it's very popular, but the people who are teaching manufacturing today mostly haven't ever done any manufacturing, okay? Our students in engineering are going through engineering programs not learning how to make things. We have mechanical engineers, and this isn't unique to any particular university. This is across the board. Overwhelmingly, our engineers don't learn how to do manufacturing. The actual doing, that's beneath them. We have a huge gap in the middle of the skills between the people that actually do it and the people that understand what needs to be done and why. And we are in perhaps the fastest changing period in manufacturing history. The way we make things, where we make things, how we make things, and who can make things are all changing at a huge pace because of digital manufacturing, which is kind of counter what I just said, that, that's not going to change anything. But the truth is that becomes an added tool to what we have. None of our existing processes are going away. Not a single process that we have used for the past 2,000, 3,000, 6,000 years is going away. We just now have doubled the number of processes we have available so that someone who is a good manufacturing engineer can choose from a much larger suite of options. So that's the reality. So where are we heading? Industry is seeking the right kind of workforce. They're struggling because they're not finding it in the normal places. So they're seeking creative ways to do that. They are seeking gamers. They are saying that degrees don't matter. If anyone's noticed, there was a big announcement maybe about a year ago. GM dropped degree requirements for a lot of technical positions because they were finding that they were having to train everybody anyway. So it was just as easy to get a good person that they could train well than a bad person that had the credentials. That's changing in manufacturing. Technology is going to change the nature of the workforce that we need. We are going to need more skilled people, but not necessarily across the board. So here's a weird thing that happens with the technology. If I implement the new types of automation, robotics, co-robotics. So co-robotics are a new type of automation that allows me to put a person working with a robot. The robot's intended not to hurt the person. Normally, it's very difficult to implement robotics, very expensive, very time-consuming, because the robot has to do absolutely everything by itself. Robots are terrible at doing most things. So it means that I have to spend a lot of time and a lot of money to make it safe to operate by itself and then enclose it so nobody get hurt. A co-robot only does what the co-robot's good at. And then it hands it to you and says, I can't tie shoes. Stringy stuff is difficult for me. So here, I'll stack all the shoes and put them in the right places, and then you tie them. Perfect, okay? They're inexpensive, they're easy to program, and small manufacturers are finding that they can use them to do automation for very low production volumes. Things that you would never consider automating. Makes the job for the person more pleasant, more productive, more cost-effective. That's the future of manufacturing. That's the type of technology that you need to start being able to explore. And what's interesting is, and I like the example earlier about the self-checkout. because that's a real good example of what's happening in manufacturing also. It creates a split in the technical skill that's required. I need somebody that can design that self-checkout. I need somebody that can program that checkout. That's a much higher level of skill than I've normally needed in those small manufacturing companies. But even an idiot like me can scan my own groceries once the checkout's made. I don't need to know how to operate the cash register. I just take the barcode and I drag it across. And it goes beep, and then I do it again. The automation is more difficult to implement, requires a higher degree of skill to implement, but I only need one of those people or two of those people for every 10 or 20 that are now able to implement it. So we're in some ways offsetting the lack of skill because of that. We also are having to recognize that there's a new product in manufacturing, and this is perhaps the biggest change that's happening today and something to consider. Where we normally think of the good, the widget, the thing that I hand you as the product, starting now and going forward, data is the product. Not only will I give you this widget, but I will tell you all the things that have happened to this exact widget, this part number, this serial number, from its entire life, from the time it was dug out of the ground until I handed it to you today. And I'm going to hand you just like its little medical record, it's going to go with it, and that digital twin and that technical data package is going to travel with that for its entirety. And right now, small manufacturers are in no way prepared for the complexities of dealing with that. They don't have the in-house support to manage the sensors, to manage the data, to manage all of that. They don't have the ability to manage the regulations. Now you're handling all that data. Moving around goods has some sensitivity. Moving around the data has a lot of sensitivity, right? And that's going to be the expectation. So what does it take now to be competitive? What does it mean to be competitive going forward in this environment? First thing is, again, you got to hold the education system at all levels accountable. And I'm very much a part of that, but I've also been fighting aspects of that from the inside for my entire career. We have to change the narrative around manufacturing. Manufacturing's good. It's a good thing. It's a good job. Had I been smarter, instead of doing 16 years of college education, which was, I guess, a long time to get a bachelor's degree, but it would have been 17 if I went to Michigan. So, had I started and left high school and gone and become a machinist, I'd have been making $60,000, $70,000 a year, 2 or 3 years out of school. So that's 16 years where I had very minimal income. If you take that and figure on average, maybe I would have made $50,000 a year, which is probably low. I dug myself an $800,000 deficit by going to college. We need to recognize that there are more than one way to have a very good career. We also need to be selective about the technologies that we explore, and that's really what I would like to convey to you today is don't get caught up with the shiny object. Don't chase STEM programs because they're going to teach you to make the next big thing. Chase them because they represent skills and precursors to skills for the workforce that this community needs. And ask the right people, because if you ask an academic that comes from purely academic, they're going to tell you that everybody's going to be making jets and cars next week. Make sure that you know how to program your plasma unit. And if you ask an old graybeard, they're going to tell you something else that's archaic. Whoever you ask, whether it's me, them, anybody, challenge them. Ask them tough questions. You as a community have to figure out what flavor this community needs. But I promise, it's not at either extreme. Somewhere in the middle. And I'll leave you with this notion. I think that there is manufacturers are historically very risk averse, okay? And the profit margins on small manufacturers are very low generally. And there's an expectation around manufacturing that it's a zero-sum game. I'm competing against that manufacturer. The stuff that's gone overseas, we just kind of take that out of the equation because that was low-cost labor. We just can't compete with that anymore. So those jobs are gone. So we increase our productivity and we fight over what's left of the pie. But what the pandemic taught us is that risk has a cost. And so now there's value in manufacturing here that people are willing to pay for because they're not willing to incur the risk. What we have to recognize is that there's an opportunity right now, a very important opportunity, that through a combination of that understanding of risk and through the available technologies that allow us to be more productive, to automate and augment traditional manual production or any traditional production to get more productivity, we now can be cost competitive with overseas production. We have to be creative about it and we have to be industrious about it, but we can do it. So it's not a zero-sum game. There is additional opportunity to be found. There's additional opportunity to be brought back into the country. And communities like this, because you have a relatively, this is a nice, cost-effective place to set up a business. This is a sweet spot for industry. And if you have the right environment to be here, if you have all the right ingredients, industry will flock. There's an interesting phenomenon in manufacturing that I've wondered about, I've pondered about for many years, and I think I've kind of processed it. Recognizing that CNC manufacturing, high-axis CNC is not new. 3D printing is 30, 40 years old. Why don't more industries use them? If we know that we can make an industry more cost competitive, why doesn't a company choose to be more cost competitive? And the answer is that there's really not much gain to it, because if you're approaching it as a zero-sum game, you're wanting a bigger piece of the pie, but you're just trying to pull it from the person next to you. So this isn't like a marathon runner trying to set a best time. You don't win gold by being the fastest. That's not how manufacturers see it. That's why they don't adopt all these technologies. The reality is it's more like 4 or 5 people running away from a bear. They're not running toward a gold medal. They're running away from a bear. And they don't have to outrun everybody. They just have to outrun the bear, or the slowest person, right? To not get eaten. Now, what that causes is that the entire community, the manufacturing community, tends to move along at the same pace. If one person pulls out a little bit further ahead, everybody moves a little bit further to catch up with them. But if somebody goes sprinting off into the distance, they let them go, because they're going to get tired out, and a mile down the road, they're barefoot. Okay? What I would propose to consider is that as a community, perhaps aspire to have a group that drafts, that runs a little bit faster than the average community, that competes against each other at a higher level than other communities. It's not the idea of trying to get anybody to sprint out in front of everybody. You're all going to have to move together, because otherwise somebody's going to get to be barefoot. Your goal should not to be barefoot. So I'll leave you with that. I wish you happy running from bears. So thank you.